Welcome. This video is on addition of whole numbers. Addition is the operation where one amount is combined with another amount to get a total. Some terminology here. The two numbers that are being added together, they're called add-ins. A-D-D-E-N-D-S, add-ins. And the answer to our addition problem is called the sum. Okay. The first thing we want to talk about is the commutative property of addition. Notice that 4 plus 10 is the same as 10 plus 4. They're both 14, right? The sum for each is 14. Therefore, the order of addition does not matter, and that's called the commutative property of addition. We have several of these properties, so you want to make sure you write this one down. Whenever you have two numbers, A plus B, you could switch the order. That's the same thing as B plus A, where A and B are numbers. And that's called the commutative property of addition. Think about the word commute. Commute means when you commute to work. The drive from home to work or from home to school. How far is it? Let's say it's 10 miles. How far is it when you go back home? Still 10 miles. That's called the commutative property of addition. So here's an example. So if they show you something like this, where two numbers are the same numbers but in reverse order, you have to remember commutative property. Okay, let's go to the next page. These are some common phrases for addition. Sum, total, increased by, more than, added to. Translate and simplify the following. The sum of 5 and 9. So the word sum indicates addition. So 5 plus 9. If we were to put 9 plus 5, it's still the same thing. And that simplifies to be 14. 5 plus 9 is 14. There's another one. 4 increased by 10. That's another phrase, increased by, which indicates addition. And again, the order doesn't matter. So either you wrote 4 plus 10 or 10 plus 4. Both of them simplify to 14. Okay. 4 more than x. Well, I kind of threw this one in there just so that you know we're getting ready for algebra. X is some number that we don't know what it is, and that's usually our favorite letter that we like to use is X. But it could be some letter. It could be another letter, Y, or A. More than means addition. So that would translate to X plus 4, or 4 plus X. They both mean the same thing. Typically, we like to put the X first for addition, X plus 4. Okay, here's a second property. It's called the additive identity property. The number 0 is the additive identity because for any number A plus 0 equals A, and 0 plus A equals A. It's called the additive identity property. It's called, the number 0 is the additive identity. It's called the identity element of addition because when 0 is added to any number, the resulting sum of addition is the original number. So it doesn't matter what number you add 0 to, you're going to get that same number. Again, it's called the additive identity element. Sorry, additive identity property. So remember, we have the commutative property, and now we have the additive identity property. Okay, parentheses. Later on, we're going to get more into the order of operations. You may have heard of the order of operations, which is parentheses, and then exponents, and then multiplication or division, and then addition or subtraction. We'll get to that a little bit later. But for right now, when you see parentheses, it's a mathematical expression which indicates do inside first. So whatever's inside the parentheses, we need to do that first. So here's our problem. 5 plus, and then we have 7 plus 3 in parentheses. So we're going to do that 7 plus 3 first, which is 10. Rewrite the 5, so bring down the 5 plus 10. And then what's 5 plus 10? Yeah, 15. Now what would happen if we move the parentheses around the 5 and 7? Well, let's do that first then. That gives us 12. And then we don't need to write the parentheses around the 12 anymore. So 12 plus 3, still 15. Notice the result is the same because the order in which the addition is performed does not make a difference. As long as we have addition here, it doesn't matter if we add the last two numbers first or the first two numbers first. And that's called the associative property. This is our third property, the associative property of addition. And it's a plus b plus c in parentheses is equal to a plus b in parentheses plus c. And again, a, b, and c, they're just numbers. We just use letters to indicate that they stand for any number. So we don't want to list all the numbers. We just want to say they're just numbers. Whether this a is the same as this a on this side. So here's an example. 4 plus 9 plus 5. 4 plus 9 plus 5. The parentheses are in different positions. Here they're around the last two. Here they're around the first two. That indicates the associative property. The result will come out to be the same. Okay, here's your first example. And you want to state the indicated property. So on your paper, you want to put the answer down from memory now, what the answer is. You might want to pause the pause the video, and write down your answers. Okay, 12 plus 0 equals 12. When you see a 0, which property was that? Right, the additive identity property. Okay, B, here we have two numbers, the same two numbers, but the order is reversed. Which property was that? Right, the commutative property, commutative. Okay, and the last one, this one has the parentheses around different numbers, but the numbers are in the same order, 3, 5, 8, 3, 5, 8. That was the associative property of addition. Okay. As we go on in these lessons, we're going to have more properties. We'll start with addition. To solve an addition problem where the addends are written horizontally, so like in our example, see these numbers, they're written horizontally. We want to rewrite the problem vertically, aligning the digits by place value. So the ones placed on the right, so here's our ones place, our tens, our hundreds. Then add the columns, carrying as you go. So 6 and 4 is 10. So a 1 up here, 0 down below. Then add this column. 5 and 8 is 13, plus 1 is 14. So put the 1 above this 4, and the 4 below. And then add these three numbers. 4 and 4 is 8, plus 1 is 9. So that's your answer, 940. I'm going to do a lot of problems in here, but if you need a lot of practice, on my website I have some handouts, and I have tons of problems, tons of addition problems, subtraction problems. They're in the handouts section on the website. So you'll see addition problems, multiplication, division, and you'll see handouts for many topics, fractions, etc. Okay, the yearly salary. Now let me go back up here. Remember, keywords such as total, more than, increased by, they're going to imply addition. The yearly salary for a human resources manager, that's a nice job, was $82,573 in 2010, $91,984 in 2011, and $104,205 in 2012. What was her total salary for these 3 years? So she got significant pay increases each year. So what's the operation here? Well, first of all, we're doing a section on addition. So unlikely that we would have a subtraction problem. And the key word here is total, or total salary. That indicates addition. So we're going to add the 3 years of salary. Now you could go ahead and add them all up by column. So I'll give you a second to add the numbers, add each column, carrying as you go from left to right. You might want to pause it and then work it out. Okay, so there's your answer. Sometimes having to add all those up, 3 numbers at a time, 3, what are they called? Add-ins. You have 3 add-ins here. Sometimes you could have 4 or 5. Sometimes it gets to be a little bit much, so what you can do is you could just add 2 of the years at a time, get that answer, and then add that answer to the 3rd year, and that would be our total, 278,762. So it's your choice. Either add all of them up at once, or add 2 of the years, and then go back and add the 3rd year to that answer. Okay, that's it for this lesson. I'll see you here for the next lesson.